Hello everyone, my name is Rahul Vishwas and I am BTech third year electrical student of IIT Bhubaneswar. So, to welcome to the experiment number 6 of digital signal processing. So, in this experiment, we need to construct a filter, design a filter to remove the baseline having a frequency below 0.4 Hz and using pole zero placement method, implementing the algorithm of Arduino using the following signal: one PPG signal without baseline, with baseline, and with baseline, and 30 Hz power line. So, and here the sampling frequency Fs is 80 Hz. So as you have seen that we need to construct a baseline below 0.4. So it means we have to construct a high pass filter so to remove the frequency below 0.4. So here so for calculating a high pass filter by pole zero placement method, we know the transfer function of high pass filter is z into z minus 1 divided by z minus r. So here z minus r, so 1 is the zero location and r is the pole location, so magnitude of the pole. So now here we can see that our f is 0.4 and fc is 0.4 and fs is 80 Hz. So obviously fc is less than fs by 4. So we are calculating the r by the formula 1 plus 2 into f 1 plus f2 into fs by fc into pi. So by calculating this, we are getting the r value as 0.9685. So r value we are getting 0.9685, and so we need to find the h value. And so by plotting this and by taking the condition that at z equals to 1 mod of at z equals to minus 1 mod of h of z is 1. So by taking this condition, we are getting our gain g as 0.9843. So our complete h of z we are getting as 0.9843 into z minus 1 divided z minus 0.9685. So by rearranging the terms, we are getting the y of n as 0.9685 y of n minus 1 into 0.9843 x of n into x of n minus 1 x of n minus x of n minus 1 the whole into 0.9843. So this we are getting. So as you can see from this equation, so here retain the similar equation to y out is equal to 0.9843 into x of I in minus x of I minus 1 and 0.9685 into y out of I of 1 minus I minus 1. So here what we are doing, here we are taking a signal x of x with a sample of 800 sample and y out. So in first case we need to only check the without baseline. So this is the x is the sample without baseline, and we need to remove the baseline. So for that we are doing this, we are passing it with this filter. So here is our filter function. So we are passing this x of I, x of n with this filter, and we are plotting the output. So in the first case, we are not worried about this without baseline 1. So we are removing this, uncommenting this. So removing this, we are only checking the output of the filter. So we are uploading this. So uploading is already done. So now you can check the serial plotter. So as you can see from this graph that our original signal is this blue one. So as you have see that our signal has negative part, lots of negative part. So this is a high pass filter. So actually we are removing the very low frequency component. So what it's doing, basically it's shifting this time domain signal in to make this average of 0. So as you can see, this rate is the new signal, so the mean value of this rate signal is always almost equal to 0. So these are doing this, so but the signal is actually a DC shift of this from negative to it is going to 0. So this is what, so from this we can conclude that our signal is working, our filter is working properly. Now in the second part we need to verify our previous answer with uh, with with baseline signal, means without baseline. So this was our signal where this y out is without baseline, but this x is with baseline. So now we are checking it with y out without baseline signal. So this is our without baseline signal y output. So now removing this, with the filter we are removing the baseline and we are checking the already given without baseline signal. So we this y out and y without, which should be almost similar. So now we upload it. So as you have seen that uploading already done. So let's now check serial plotter. So see, as you can see from this, that our this is our actual signal and these two is our one is the red one is our previous that y output and this is without basing. So as you can see, these are almost similar, but in spite of the fact that some part it is little bit of the deviation, because the pole zero placement method is not a perfect placement method, but it is nearly a perfect one. As you can see from the graph, it is almost equal to this red and green are always almost equal. So you can conclude that this is not a perfect one, but it is almost nearly to perfection pole zero placement method to finding the filter coefficient. So now we come to the third part of our question. So now we have to construct, we have to pass this same filter with a baseline of 30 Hz power signal, but we don't need to remove the power signal power line component. So we have a 30 Hz power line signal and we are giving it to this filter, and so we are checking the output. So here xp is the power line input we are giving. So now let's give the input as power line input xp. This is also xp. So now we are checking this power line signal, and so we need to remove this because we don't need the without baseline one, as we know that without baseline and this with this filter we will get the same result as you have seen in the earlier case. So we don't need this one. So let's uncomment this. So it is uncommented, so we are all good. So now we upload it. So our uploading is already done. Now we can check the monitor serial plotter. So see, this is our original signal with original power line signal with baseline with power line of 30 Hz, and this red one is our signal after passing to the filter. So in this case also it is the mean value of this is almost equal to 0 and it is just a DC shift of this. So by this you can conclude that this is a high pass filter and the filter is working properly in this case also. So thank you one and all, and we will meet again with next experiment next. Thank you.